This video will begin our discussion about functional groups. This topic is quite expansive, so it'll cover the next couple of videos. In this video, we will discuss our most basic organic molecules and the functional groups we can derive from them. Before we do that, let's define what a functional group is. A functional group is a common and specific arrangement of atoms that have a predictable property and reactivity. These functional groups are recognizable across a numerous number of molecules and compounds. Being able to recognize and define functional groups when you see them is critical in being able to predict a reaction or property of a molecule. In organic chemistry, we focus on studying carbon, and the most basic molecules we can have in organic chemistry are hydrocarbons, or simply chains and rings of carbons with only hydrogen connected to them. We divide hydrocarbons into three main groups: alkanes, alkenes, and alkynes. We also have cyclic and aromatic hydrocarbons, which come up later in the course, but we'll briefly introduce them later. Alkanes are hydrocarbons that contain only carbon-carbon single bonds. Alkanes have the ending -ane. Alkenes have at least one carbon-carbon double bond. They could have single bonds and multiple double bonds, but cannot have carbon-carbon triple bonds. Alkenes have the ending -ene. Alkynes are hydrocarbons that have at least one carbon-carbon triple bond. Even if the molecule contains carbon-carbon double bonds and single bonds, if it contains at least one triple bond, it is now considered an alkyne. Alkynes have the ending -ine. Just to clarify, when we classify hydrocarbons into either alkanes, alkenes, or alkynes, we only consider bonds between carbons. Here are some facts that may be interesting to you. The gas you light your stove with, or the petroleum you fill your car up with, except if you drive an electric car and use an electric stove, are the most common sources of alkanes. Industrial processes very often use alkenes to create other stuff, and when supermarkets or farms want to ripen up fruits, they often use some type of alkynes. Before we get into aromatic hydrocarbons, I want to talk about how to name hydrocarbons. Once again, this only goes for molecules that exclusively have carbon and hydrogen. We name hydrocarbons depending on the number of carbons and the shape of the carbon chain. For now, let's deal with the most basic open chain forms of our hydrocarbons. The first four alkanes are called methane, ethane, propane, and butane. Methane is our simplest hydrocarbon with only one carbon. Ethane has 2 carbons, propane has 3 carbons, and butane has 4 carbons. I know remembering these names may be daunting at first, so I like the mnemonic My Excellent Protein Bars. MEPB. After butane, we name hydrocarbons deriving directly from the number of carbons. For example, 5 carbons would be named pentane, 6 carbons would be named hexane, and 7 carbons would be named heptane. These names are mostly intuitive, so take a screenshot of this chart to remember your prefixes. Notice that all of the alkanes we just mentioned end in -ane. If we made any of these an alkene or an alkyne, the prefix doesn't change, and only the ending changed to -ene or -ine. Obviously, since methane contains only one carbon, it can only exist as an alkane. The naming part of organic chemistry traverses into the next module that we will cover. But I like to cover hydrocarbons naming first, because it tends to make the next topics in this chapter a little easier to discuss and understand. Also, it's worthwhile to start using these names earlier, so you memorize them faster. I want to mention cyclic and aromatic compounds. When we create a ring, we simply add the prefix cyclo to the hydrocarbon we already have. The simplest cyclic hydrocarbon is cyclopropane, but if it were an alkene, we would call it cyclopropene. The same goes for cyclobutane, cyclobutene, cyclopentane, and cyclopentene, etc. Although we technically could have cyclopropyne and cyclobutane, we really haven't been able to get stable scientific evidence of their existence. We'll be able to understand why that is a little later in the course. In general, cyclic alkynes begin to occur with cyclopentine. Aromatic compounds are more important for later in the course, in organic chemistry too, but we will briefly define it right now, so you'll be able to recognize them when they come up. When we talk about aromatic compounds, we often use the molecule benzene as an example. Benzene is like cyclohexane, but if it had alternating double and single bonds. This arrangement of bonds is so important because the electrons in the ring are completely delocalized around themselves. This gives benzene interesting properties. There are many types of aromatic compounds, but we introduced them later. Fun fact, the name aromatic comes from literal smell. Aromatic compounds tend to smell good or have a good aroma. Although I do not recommend sniffing chemicals, if you work with aromatic compounds in your organic chemistry lab classes, you may notice how good they smell. In this video, we talked about hydrocarbon, cyclic, and aromatic compounds. In the next video, we'll continue our discussion of functional groups.